This is Josh White with JW Math Tutoring. Today's video is going to go over 10 problems from the August 2024 Digital SAT Math section. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin the second video on 10 more problems from the August 2024 math section of the digital SAT. I do want to mention again a couple things. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. Also, most of these questions are going to be done as free response, student produced response questions, not multiple choice, even though some of them on the test were probably multiple choice questions. But because we don't have an actual copy of the test, whatever the person remembered maybe didn't include all the answer choices. Okay, so just be aware there could be other ways to solve some of these problems if they were multiple choice and you had possible answers in front of you, but I'm going to solve them as if they were free response type questions. All right. So with that being said, this first question here looks fairly complicated. However, it actually is not. And it also can be solved entirely in Desmos as well. So first I'll show you kind of the theoretical way to solve this. And that is basically you have to know that the cosine of 90 minus an angle is just going to be equal to the sine of that same angle, and vice versa. And the same thing is going to be true with the sine of 90 minus an angle being equal to the cosine of that angle, in this case A. So if you just substitute those two things in, what all you end up with here is really like sine of B times sine of B plus cosine of A times cosine of A. So this is just really sine B, which is 0.39 squared, plus cosine A, which is 0.5 squared. And you just go ahead, go to the calculator, and add those together. So final answer would be you could enter in 0.4021, or you could technically put the leading zero in front of it. Again, 4021, or you could technically also write 0.402 if you want to put the zero in front of it. Either of those would be considered acceptable. Now, let's say you didn't know those cosine and sine properties. Basically, it's properties of complementary angles. But here's how you could still solve this entire thing in Desmos. So you're told the cosine of A is equal to 0.5. All right. So I'm just going to use inverse cosine and do that for 0.5 to figure out what the value of A is. Now, of course, I need to change this and make sure that it's in degrees. Click on the wrench up there to do that. All right. So we have the measure of angle A. Let me just slide this over here. Now let's do B. So we're going to do inverse sine. Okay, that's what angle B is equal to. So now all I have to do is just type in this exact thing as it's written, cosine of 90 minus B times sine of B plus sine of 90 minus A. I'm using capital letters, of course, because that's how I defined them in my previous steps, times cosine of A. Notice I get the same exact answer, 0.4021. Okay, so again, this is how you could solve this problem entirely in Desmos by just figuring out the actual measures of the angles and then just punching them in to the formula. Next question dealt with percentages. So on this one, the first thing I'm going to do is I'm going to convert these words into an equation, which would be A equals 4.98B. And then you could convert the second one into an equation, which is A equals, you just have to be careful. So this is 0.83%, which means we move it over, it turns into the decimal 0.0083. Now, since these are both equal to A, we can just set them equal to each other. So 4.98B equals 0.0083C. And here's where you have to be careful. What percent of B is C? Okay. So what that means is they're looking for a final equation that's going to be like X percent or X, whatever, some number times of its multiplication, B is equal sign C. So we're looking to solve this equation to get C alone by itself. So you just divide by 0.0083. C is going to turn out to be, and we can just do this in Desmos if you want, equal to 600B. Now, that's what our X value is here. But the problem is it's asking for percent. It's not asking for like how many times, B C is equal to. It's asking for what percent. So you have to take the number 600 and multiply that by 100% to convert it to a percentage. So the final answer for this is just going to be 60,000. In other words, C is equal to 60,000% of B. In other words, to get C, you multiply B by 600. In other words, you take the 60,000%, and of course you would move the decimal over 2 places. That equals to 600. So correct answer you would submit for this one is 60,000. Next, you have basically one that deals with problem solving, data analysis, specifically like survey design. So basically the idea here is the survey was given to students, high school students in this specific school district, okay, from the various high schools that are in it. The largest population that it can be generalized to are just going to be all high schools in the district because that's where your survey population or your survey sample came from. You cannot generalize this to all high school students in the state when you only polled one school district. And you can also, and so, that's why this one doesn't make sense. Obviously, you can't generalize this to even further than that, all high school students in the United States. And then for C, you assuming that the survey was designed properly and administered properly, and it appears it was, random sampling, like we can generalize these results to more than just the 353 people that took the survey. We can apply it to a larger population of which those 353 are presumably a representative sample from. So that's why C is incorrect. So the correct answer for this one would be B, all high school students in the district. Next up, question number 4. We have one which looks very tricky. It actually took me a little while thinking about this to figure out the correct way to solve it. Initially, I was thinking about taking this 36 and putting it into the radical, so it would become the square root of just a whole number with nothing in front, and then like trying to relate the two somehow that way. But the easiest way, and it's actually not going to be that much work to figure this out, is to go ahead and square both sides. That will cancel out the large radical on the left. On the right, you technically have to FOIL this. So that means, it's going to be r plus root p times r plus root p. When you FOIL this out, you will get r squared, and then the inner and outer terms are going to be the same. They're both going to be r square root p, and then root p times root p is just going to be p. So now you can match up essentially or equate it's like the terms that look the same or that have the same format. So what that means is 36 root 6 has to equal this right here. So in other words, 36 has to equal 2r. Therefore, r has to be 18. Also, 6, the number to the radical, has to equal p. Therefore, p has to equal 6. So what is r plus p? Well, it's just 18 plus 6, and it is 24. And that is the final answer to this problem. Now, just to confirm that this is correct as well, if you take r squared, which is 18 squared, and you add to that p, which is 6, notice you get 330. So these two terms here do equal 330, which matches, this number that's out in the front. So that just confirms we have the right number. So correct answer for this is just 24. All right, the next question. This is another tricky one. Haven't really seen anything like this before, but it's actually not that difficult to figure out. So basically what's going on here is that you know it goes through these 2 points, -6 whatever and 0 whatever. And they want to know what's the value of f of -4 plus f of -10. The whole thing with this problem is that because of these squares right here, when you plug in -6, okay, for x, so you have -6 plus 5 squared, okay, minus b, and then don't worry about the a out front, that's irrelevant. And same thing here, -6 plus 5 squared minus c, okay. The whole point is inside these parentheses you get -1, okay, both of them. And -1 squared becomes 1. So what you end up with is like a times 1 minus b times 1 minus c. And whatever a, b, and c are, we don't know what they are, doesn't really matter. That is equal to 20. And what turns out to be true then is if you plug in -4 right here, because of the way this graph works, it's going to be symmetric, and you'll see that. Actually, I'll show you we can do this in Desmos as well. If you plug in -4, you're going to get the same number when you square the parentheses. So -4 plus 5 is +1. 1 squared is still 1. So the point is, when you plug in -6, you get some expression that equals 20. But when you plug in -4, you get the exact same expression. Therefore, f of -4 has to equal 20. The same thing's going to be true with the 0 and the -10. Notice they're both the same distance away from the 5 here. Because like I said, if you take 0 plus 5, right, and you square that, you get 5 squared, which is 25. And that's for both parentheses. But if you take -10 plus 5, okay, you get -5, but you square that, you still get 25. So it's the same exact situation where you get the same exact expression. It's a parentheses 25 minus b parentheses 25 minus c equals, 512. So the whole point here again is the f of -10 is just equal to 512. You can add these together. And so our final answer should be, just double checking, 532. Okay, so that's the correct answer for this one. Now, you actually can do this in Desmos though, just to show you. So maybe you find this to be quicker, maybe not. So all we're going to do is enter in the points that we know. Then we're going to do a regression, and we're just going to enter it in exactly in the format that it's given. Okay, so let's see here. X is 5 squared, x is 5 squared, yes. Okay. Wait, are those just making sure. Yeah, those are multiplied by each other. Okay. So we enter the values in. It gives us it gives us values for A, B, and C here. Now they're not exact. So basically what we would want to do is we need to find the values of x equals -4 and x equals -10. So you could either type out the function and you can enter those values. Because they're not exact, what I would do is I would do x equals -4, and now I'm going to see where does it intersect the function. Okay, oh, it's right there, +20. So that just confirms, again, it's the same value as -6 has. And then I would do 0. That's just going, and that one we actually don't even just type in, because that's going to be the x-intercept. Now the problem is, to scroll for a ways here, okay, and we can see it right there, it's 512. You know what I mean? Already highlighted. So this is how you could do it and get the answer in Desmos, and then of course you would just add those two, 20 plus 512, 532, entirely, via that method. All right, next up, the sixth question in this second series of 10 questions from the August 2024 test. We have here a circle and we have an equilateral triangle which is inscribed inside of it. So let me see if I can get a rough picture up here. Here is our circle. Let's see here. Okay, this obviously is not equilateral, but whatever. Let's just pretend that it is for these purposes. So we know that the total perimeter is 780. Okay, so we can divide that by 3, and that's going to give us 260. So that means each side of this triangle is 260. We also know they tell us the circle has a radius of a root 3. So basically, here in the center of the circle, okay, there's multiple ways you could draw or divide this up, but here's a radius and here's a radius. Ignore the poor drawings, of course. This is a root 3, this is a root 3. So what ends up happening, and I'm just going to draw a separate picture to kind of illustrate this, is basically like this is 60, you know, this whole angle 60, this whole angle 60, but what it ends up splitting this triangle into is basically this is 120, this is 30, this is 30. Okay, this is a root 3, this is a root 3. This is just a kind of like a magnified portion of this triangle right here. Then we drop this down. It makes two congruent triangles. Again, ignore the poor drawing. This is 60, this is 60. So now what we have to do is basically this whole thing down here is 260. So it gets split up into 130 and 130. All right. So now what I'm going to do is this is 130 is the long leg in the 30, 60, 90 triangle. So I'm just going to call this x for the short leg. And I know that x is equal to the long leg, which is 130, divided by root 3. So if I go ahead and do that, and then technically simplify it by rationalizing the denominator, I get 130 root 3 over 3. So that is the vertical, that's this vertical side right here. It's the short leg in our 30, 60, 90 triangle. Now to get the radius, I just have to take this and multiply it by 2. Radius is also the hypotenuse of this triangle. So 130 root 3 over 3 times 2. 260 root 3 over 3. So that's what the hypotenuse of this triangle is equal to, and this is equal to a root 3. Okay, so that means that a technically is equal to this right here. So you can input 260 over 3. You could also input 86.66 if you wrote the decimal form and you truncated it, or you could put 86.67. Okay, so the a value for this circle, which is part of the radius measurement, is either one of these, you know, 3 acceptable values: fraction, truncated decimal, rounded decimal. Next up, we have question number 7. Here we have one that dealt with basically proportions and area. So we have a square map. Each side of this map, 55 inches. All right, 1 inch on this map represents 13 miles. Now, there's a smaller version of the map, and the side lengths are 70% smaller. So if we just start with 55, we take 0.7 times 55, we subtract that from 55, we get 16.5 inches. So the smaller map is 16.5 times 16.5. So now basically what we're saying is this small map, which has a side length of 16.5 inches, okay, that has to represent a total distance of 55 times 13. Because in the large map, you know, like 1 inch is 13 miles. So that means in the large map, basically you have 55 inches times 13 miles per 1 inch, and that just comes out to 715. So the small map is representing the same total distance, the same 715 miles, but we only have 16.5 inches to do it. So, what is the actual distance represented by 1 inch on the small map? Well, we just divide this by 16.5. So if you do that, it should come out to 43.3 repeating. Let me just double check these calculations in Desmos. So we've got, first of all, 55 times 13, okay, 715 total miles. And then we're just going to divide that by the 16.5 inches, which is the side length on the small map. Yep, 43.333 repeating. So you could put the answer in as 43.33. Let me see if there's a simplified fraction. Easy simplified fraction? Yeah, or you could also do 130 over 3. Okay, so 43.33 or 130 divided by 3, either of those would be acceptable. Question number 8, here we have two triangles. So I'm just going to sketch them out real quick. ABC, and we have X, Y, Z. We know that these two sides are each 45, therefore they're congruent. We know B is 60 degrees. We know, all right, that should be a type. That's a typo. I'll have to fix that. I'll fix that in the file. It should be Y that is 60 degrees corresponding angles. And we're also told AB to XY, whatever the ratio of that is, AB to XY equals BC to YZ. Okay, so what additional information is needed to prove these two triangles congruent? So the correct answer for this is actually D. You do not need any additional information. And the reason is because, okay, we already know that the ratio of BC to YZ here is just 45 over 45. In other words, it just becomes 1 to 1. So AB to XY has a ratio of 1 to 1. That means whatever AB is, XY is the same, okay? We don't know the exact values, but we know that this will be the same length as this. And if that's true, then these two triangles can be proved congruent using SAS. We have one pair of congruent sides, we have a pair of congruent angles, and we have a second pair of congruent sides, and the angle is included between the two sides. So therefore, by SAS, these two triangles are congruent based on the information we're given. So the correct answer for this is D. Next up, we have question number 9. And on this question, basically we have a rectangle inscribed in a circle. So go ahead and get a picture for this. All right, and we're also told that the diagonal of the rectangle is twice the length of the shortest side of the circle. So the diagonal would be right here. It goes to the center. So we 2x and say this short side is x. We're also told that the circle has a circumference of 152 pi. So the circumference of a circle is just equal to pi times the diameter. Now, if you wanted to, you could also technically set it equal to 2 pi times the radius, if you didn't remember, pi times the diameter. But either way, so if you do it this way, you just get the diameter is 152. If you do it using the other equation, you're just going to get, dividing by 2 pi here. Pi's cancel out, of course. 152 divided by 2. You just get the radius equal to 76. Then you would have to double it to get 152 because the diagonal of the rectangle is also a diameter of the circle. All right, so this side right here just equal to 152. Now, that also means that the short side of the triangle is going to be equal to half that, or the 76, which is actually the same as the radius. So this side in your triangle is going to be 76, okay? Now, in order to find the area of the rectangle, we need to find the area of this third side. There's two ways you could do it. The short, quickest, easiest way to do it is to recognize that this is a 30, 60, 90 triangle because the hypotenuse here, is twice the length of the shorter side. So that means this has to be 30 and this has to be 60. And that would mean that this side down here would be 76 root 3. And then you could find the area by multiplying, the length and width, which is 76 times 76 root 3. And if you do that out, that will give you an answer of 5776 root 3. Now, a couple things to point out. First, if you didn't remember, didn't recognize this is a 30, 60, 90 triangle, that's fine. You can use Pythagorean theorem, and I'll show that in a second. But also more importantly, this question was reported as a multiple choice question, not a free response. So that means when you're looking at the answer choices, like the correct answer choice is going to look like this in this format, with the 5776 root 3. Okay, so now let's say you forgot about that and you wanted to use Pythagorean theorem. All right, so whatever, I'll just call this side A. So we've got A squared plus B squared, which is the 76 squared, equals C squared, the 152 squared. And then just subtract this on both sides. Okay, so now if we go to Desmos, we can, first of all, you could do 152 squared minus 76 squared. Okay, it's just 17,328, and then the value for A is just going to be the square root of that. Okay, so what I would do is, you put parentheses here, you could type in the square root. Oh, it's not going to allow you to do that. All right, so we'll just go to the next line, 7328. Okay, so there's the value of A. It's like approximately 131.64, but we want the exact value. We don't want to round it off or truncate it in any way. We want the exact value to come through. So then what I would do is I would define this as a capital A, and then I would take that and I would multiply it by the other side of the rectangle, which is the 76. This is my area, okay? So when you multiply this, the bottom side, which is, again, approximately 131.64 times 76, you get for the area 10,004 point whatever. 3255. 3255. Okay. Now, what you would have to do then is you would have to go to the multiple choice answers and you would have to calculate them each out to see which matches this number. Okay? And it's going to be this right here. And we can just go back to Desmos to confirm this. So for example, 5776 square root 3. Okay, see, we get the exact same number. It matches up perfectly. All the decimal places it displays are identical. So if you did not remember and recognize that it's a 30, 60, 90 triangle and instead you use Pythagorean theorem to find the third side, that's perfectly fine. You just have to do a little extra work of, once you find the area, figuring out which answer choice is the same decimal equivalent as the number that you get, the 10,004 point, whatever, 3255. All right, for the last question here, we have a word problem that deals with 3D shapes. So basically, we have a rectangular prism here. It looks something kind of like that. The height of this is going to be 24 inches. The width is going to be 4 feet here, and the length is going to be 20 feet. And we're given a total cost to fill this, and they want to know the overall cost in terms of dollars per cubic yard. Okay, so there's a couple things going on here. First, we need to find the total volume of this prism, but we need everything to be in the same unit. So what I did first is I converted the 24 inches to just 2 feet. Okay, and then I said, okay, the volume is going to be length times width times height. So we got 20 times 4 times 2. So the total volume, and again, this is in cubic feet, should work out to 160. Now what you have to do is you have to convert that to cubic yards. So 160 feet cubed, and then times 1 foot is 3 yards. And you have to do that 3 times because it is a volume, because it's 3 dimensions. Now, if you didn't want to write out 3 times, you could technically just take this and you could cube it, and it would be like 27 on top over 1. So if you wanted to do it that way, I mean, that's fine. Basically, the whole thing is you're going to end up multiplying. Oh, sorry. These are all backwards. It should be 3 yards. 3 feet is 1 yard. Gets smaller, not bigger, for number of yards. 3 down here, 1 up here. Okay. So now, if you go ahead and just do this out, multiply it all through, it should come out to 5.9259 cubic yards, the total amount of soil needed for this. Just go to Desmos to test, confirm that this is correct. So we got 160, and then it's times 1/3, times 1/3, and times 1/3 again. Yep, 5.92599259, but yeah, whatever. It's really just 160. You could also keep it as 160 over 27, if whatever you want to do it that way. That's fine. All right, so now this is the total volume in cubic yards. They want to know the cost in dollars per cubic yard. So now dollars on top, cubic yards on the bottom. So we put the $231 on top. We put the 5.9259 blah, blah, or if you want to use 160 over 27, either way, you put this, just type this into your calculator, type this into Desmos. The answer that we're going to get is going to be 3898, rounded to the nearest cent. Now, a couple things. So first of all, again, if you wanted to divide 231 by that value, I would not just type it out by hand. What you want to do is you want to define this as an exact value, which is called V. And then down here, I'll type V and it'll carry over. And so notice here it's $38, and then the rounded to the nearest cent would make it 98 cents. If you type it out as just 5 point, even if you go 9259, 2592593, you could end up getting it slightly wrong. The rounding may not work out to be the same, but when I define it as V, it's using the exact value. It's not rounding it at all. And of course, you could also put 160 over 27 and, do it that way and get the same answer. But correct answer for this one is just going to be 3898. All right, so those were 10 more problems from the August 2024 Digital SAT Math section. If you have any questions or comments, or if you know alternate ways to solve some of these, please do leave them in the comments below. If you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications. But otherwise, check out part 1, first 10 questions if you haven't done so already. And also check out part 3, the last in this series of August 2024 questions, as that'll be posted very soon.